All right, in this video, we're going to take a look at solving problems involving Poisson probability distributions. I always want to say Poisson, but it is pronounced Poisson in French. So a Poisson probability distribution is a discrete probability distribution. Again, so the values are countable. Um, that involves occurrences of some event over a specified interval, such as maybe time or distance or area or volume or something like that, something we would measure. So Poisson probability distributions have the following characteristics. First up, the experiment consists of counting the number of times, x, an event occurs in a given interval, much like we have in the past with other probability distributions such as binomial. The probability of the event occurring is the same for each interval, so again, just like binomial distributions. And the number of occurrences in one interval is independent of the number of occurrences in other intervals. So again, there's that independent events that we looked at with binomial distributions as well. So here's our formula for Poisson probability distributions. We have this population parameter, the mean here. So again, the mu Greek letter is the mean number of occurrences of the event over the intervals. So we have mu, the mean to the x power, times e to the negative mean, and e is about 2.71828. So most calculators have an e or exp button, which will use this as the base of the exponent. And that's all divided by x factorial. So remember, x factorial meant like 5 factorials, 5 times 4 times 3 times 2 times 1. You just count down to 1 and multiply all the numbers in between. But that is the formula for the Poisson probability distribution. All right, example 3. The mean number of dogs adopted from a rescue center per month is 4. Part A, what is the probability that in any given month, 5 dogs will be adopted? So we want to find the probability that x equals 5 dogs that are going to be adopted if the mean number per month is 4. So we're going to have 4 to the 5th power, the mean to this value of x, the 5th power, times e to the negative 4th, all over 5 factorial. So let's go ahead and I'm going to use Desmos for this one. So my probability is going to be, I'll just hit divided by 4. I'll just do this on the keypad here, although you can use your keyboard as well. 4 to the 5th power times, and to get e, you could go ABC and press this e. Desmos does reserve this e as that 2.718 number, but also you can use under miscellaneous, if you use this exp, that'll work as well. So exp and then negative 4, I believe was is the mean, and then over 5 factorial. And to get the factorial, just click the ABC button right down here, and here's your factorial right there. So we got about 0.1563 if we go to 4 decimal places. So about 0.1563. So there's about a 15.63% chance that 5 dogs will be adopted in a given month if our mean number is 4. So hopefully they'll go to good families because they deserve it. All right, part B, what is the probability that in any given month 2 or less dogs will be adopted? So 2 or less, find the probability for 2 or less, that's less than or equal to 2. We need to find the probability that we adopt 0, 1, or 2. Unlike a binomial distribution, Poisson distributions don't have that fixed number of trials. So we could have, millions of occurrences happen in a given amount of time with Poisson distribution. So maybe the entire kennel gets adopted out, which would be great. But we want to calculate the probability for 0, probability for 1, and then the probability for 2 and add them up. Because again, with probability distributions, these are mutually exclusive events, each one of these probabilities. So to find the total probability, we can just add 3 and not have to worry about subtracting out any of the ands. So you get about 0.2381, which is what we would get if we did 4 to the 3rd, 4 to the 0 over 0 factorial, 4 to the 1st, 1 factorial, and 4 to the 2nd and 2 factorial. I do want to show you, and I'll put a link to this in the description. Much like with the binomial distribution here, created a calculator for Poisson probability distribution. So I'm going to run this. We have 4 on average, and we want 5. Although for this one, we really don't have to go all the way to 5, but whatever, it's okay. And then the decimal place that we're going to round to. So again, this is our mean, our mu, number of successes, that's our x in our formula, and then we're going to have 8 decimal places for our table. So let's go ahead and run this. And again, I'll put this in the description, so all you have to change is the mean. And then if you want to change how far down your table goes, you can change this number as well. So that way you don't have to worry about any of this stuff. If you want to explore it, it's under Python's SciPy stats module, which I've used quite a bit, and I will continue to use quite a bit. But anyway, yeah, you can just change the mean and change the number of successes, or the last row of your table here. And notice that with our x equals 5, x equals this 5. Here's our 15.63 down in this one. And if we change the decimal place to 4, we'd get 15.63 here. And R said less than or equal to 2. We said 0.2381. So our less than or equal to is right here. Less than or equal to 2, here's our 0.2381. Here's where it's greater than or equal to. So if we need to do that one, we can use this column as well. So I will again put a link to this program in the description. And again, if you want, you can just go search online Python IDE, and then you should be able to paste the code that'll be in the link directly in there and be able to change it without having to worry about downloading a bunch of programs and stuff for your computer. Although you're more than welcome to do that too. So again, there's about a 23.81% chance that 2 or less dogs will be adopted in a given month. All right, part C, what is the probability that at least 3 dogs will be adopted? Well, we could do that 3 or more means 1 minus 2 or less, which is our answer that we had from the last one. So we get about 0.7619, or about 76.19%. However, using this, at least 3, at least is this column, this last column, greater than or equal to 3. And here's 3, so we have 0.7619 down here in this table. So we have about a 76.19% chance that at least 3 dogs will be adopted in a given month, which seems about right considering the average is 4 for this particular distribution. All right, so mean and standard deviation. The good news is mean and variance for Poisson distribution is the value that's given to us. So the mean of 4 dogs is the mean of the distribution, which is really nice because we're given that already. And on top of that, it's the variance for that Poisson distribution as well, which means the standard deviation is the square root of variance, which in Poisson's case is the square root of the mean. So to calculate this mean and variance of the standard the mean and variance of a Poisson distribution, it's the mean that's given to you also happens to be the variance as well. Since that's the variance, take the square root of it, you'll get your standard deviation for Poisson distribution, the square root of the mean. All right, that about does it for this video. Thank you for watching. I will see you next time.